Okay, so last time we have built like the basics of Carla Simulator, and this time maybe using lane detection and using the waypoints that we get. I'm not like going to use like Python. I'm not going to like doing any pre-processing in this part. Particularly, I'm just going to get the waypoints using the function world.get waypoints, and then using PID controller. PID controller is basically like proportional integration derivation, and using that, I'm gonna control the steering and throttle of the car. I'm not gonna like give a shift and all. It's gonna be pretty basic stuff. You must have seen that in the Coursera course, where they use like Stanley suppose for lateral control. I'm gonna use like a PID controller for both longitudinal as well as lateral control. So let's see how it is. And if you haven't watched the setup and installation and different stuff that I did with the previous part, definitely check out the video. It will be here in the I button. So do check that out, and let's get moving with how we will be building the introduction and doing the code stuff. So let's get started. So I'm going to start with opening a PowerShell. I'm needing two PowerShell today, like last time, and let's open to PowerShell. And let's set the location. So actually I'm out of storage right now. That's why I have moved my whole setup to D. And so let me first just go there. So this is where my Carla Simulator is, and here is in the code that I'm going to write is going to be here. So let's go here as well. Cd temp window Python API examples, and what we're needing is to create a new file. So Sublime text, I'll create a new file, I'll save it in the particular directory, and I will name it second.py. Okay, this is my first.py, and I have changed it a bit. I was doing some other stuff, working out how I'm going to do it. But to begin with, I'll be needing a few import libraries. This is very important. Otherwise, Carla isn't going to work. So I need this. You can just copy it from any particular file. Like if I just open it with Sublime text, this you can copy it from here as well. This is basically the path that I will be needing. So let me just. Also, I will be needing to import few other a lot more libraries that I didn't be needing. So let me just import them. So I'll be needing math. So I'll just import math for square root as well as for radians for sine cos. I'll be needing, obviously, I'll be needing glob OS. I'm using them here. You can see, as well as this. NumPy for mathematical computation, and I'll be saving NumPy as NP. Third thing I'll be needing is CV2. I have already talked about how to I will talk about how to save, how to install these things in my previous part. But just a reminder, you have to be, I think, admin. PowerShell has been admin, and just write like pip install whatever you want, like NumPy sorry, wrong. NumPy, it's already there. I don't need to like, you can install anything that you want like this. You will be needing OpenCV for CV2. I haven't done any image processing, so CV2 isn't required up to this point, but from next time it will be. So it's good if you have it installed, although not required for this particular part. Okay, so next thing I need is I think this pretty much is, I need queue as well. Here I will be putting my errors and changes. Then I'm going to use PID controller on that, and you will see what I'm talking about. Before that, let's build a basic setup for a Carla. Okay, let's create a def main function. Although from next time, I think I'll be using a more class-based approach, because I've seen like some situations where the car just gets stuck. So I'm needing to look at a collision. Look at like if there is a collision and it's not like stuck, the car is stuck. I have to recreate the episode. Say so. So I need actor list. Then I'll be using a try, and here everything is gonna be like wait a minute. First of all, let me just have finally as well. Otherwise, I'm going to forget this thing, and actors are not going to be destroyed. I need this thing. So I can do is client dot apply. Yeah, I know I haven't created a client variable. I will just in a moment. But I always forget to destroy the actors and destroy actor x for x in actor list. Okay, let's create client now. Client is equal to Carla dot client, and I will be passing the localhost and the port. Okay. Next thing I'm set is a timeout. It will like look for like 5 seconds, let's say. So client dot set timeout, and it's going to be of 5 seconds, and I'll be needing a hold. So I'm just going to go with the basic setup that we get. So client dot get hold. I'll be needing a map. So world dot get map. Next thing is I want to create a vehicle, but for that I need blueprint library first. So let's create a blueprint. Let's create a variable blueprint library. If I make any spelling mistakes, don't mention the comment section, please. Get blueprint library, and is right. Yes. Now let's get the blueprint for a car. I'll be using a Cybertruck. I love those. Blueprint is equal to how do you say it? Blueprint library dot filter Cybertruck, 0. Let's get the spawn point and rotation as well. So let's say spawn point is equal to Carla dot transform non-regulating not importing transform location and rotation from Carla. I can still do it, but Carla location like this points I have got from trial and error. You can say like you can just try yourself different points and go with one that suits you, like not falling on traffic lights. So whatever that point is, go with that. 0.05 and 7 is equal to 15. Just check it if it's still recording. One time, I don't know how, but it stopped recording in mid and I was keep going. Like I was, let's leave it. Let's focus on rotation, pitch. These rotations are also like XYZ rotations, so like pitch is for the rotation around the x-axis, Z is around y, and the roll is around z-axis. So let's go like pitch equals 0, y equals 180, and roll equal 0. Yep, I think that was a spawn point I needed. And let's create a vehicle now. Vehicle world dot spawn actor vehicle blueprint and the spawn points, and I'll be needing actor. Now let's append it to the actor list. Dot append and vehicle. Okay, so this is basic setup for a vehicle. Now what we need is to create an object for a class. Let's just create a class here. We're gonna name it vehicle PID controller, and let's create the init function. Here I'll be passing self. I'll be passing KP, KI, and KD for the for lateral as well as for the for the lateral as well as for the longitudinal. So I'll be like args lateral, args longitudinal. I'll be needing max throttle, 0.75, max brake 0.3, and max steering. These are the values that you can tweak around and check for yourself. I'm going with these. It's up to you if you want to go with these values or not. And let's just do it like this: max steering and self dot. What was the last? Max throttle. Self dot I have to pass vehicle as well. I think I forget that thing in between. Yep. Self dot vehicle is equal to vehicle, and self dot world is equal to vehicle dot get world, and I'll be needing what I'm going to do next is create two more classes for lateral as well as longitudinal control. So what I can do is class PID longitudinal control, okay, and it's going to be asking for an init function, obviously self vehicle kp equal 1.0. I am going to set ki and kd in this particular case equal to 0, although in little parts I'll be changing the value because I've seen that I have to put some value and figure out what. But so I'm going to put ki and kd here, but I'm going to show you how to calculate it, how to calculate the differential and integral components and then add them up. So ki and ki equals 0.0 and change in time which is going to be 0.03. Although I'm providing these values default, I am going to pass them through the, when I'm creating the object, I'll be passing through. That's why I have these arcs longitudinal and arc lateral. So let's create the self function self dot vehicle is equal to vehicle self dot kd is equal to kd self dot kp is equal to kp self dot ki is equal to ki, and I have to create a error buffer where I'll be storing the changes. How should I say this? You know what? Wait a minute. Whenever you read the code, so then you can understand what this this DQ is. But let's just suppose it's something for now. Let's put in the code. Just in a moment, I will show you what the actual uses. But this is very important, and we're gonna have a max length of. Although I'm really surprised that like I was stuck on this program for like 2 weeks, and when I figured out how to do it, it was really easy. To be honest, we should actually check the Carla forum. I think that has got more material, or it's like it has got like more information about Carla than their documentation, because people ask questions, people explain things. Sometimes you have same questions and you get, I mean, you can understand what I'm saying, like, right? So I've got another class, lateral control, and they're going to be having a same customer function. I will pass in vehicles arrow first. So let's now create the objects in our vehicle control class, and where it is? Yep. Here it is. So self dot long controller, and let's PID global controller. Let's pass self dot vehicle and our args longitudinal. You know, like why we are passing system error, because args longitudinal control KPK and KD and variable length. So that's why we are using this double pointer, not like pointer. I mean, not remember the name. Self dot lat args let no self dot let controller equal PID letter controller, and I'll be passing self and args lateral. Yep, this is it for the construction of two classes. Now let's get to the meat of the video, like why we are actually here for. uh let's create a while true loop here first, and then I need is waypoints. Although in the next part I will be using image to get the waypoints, but here I'll be using this, I think, a Python API to get the waypoints. So I'm using like world dot get map dot get waypoints vehicle dot get location. This will give the waypoints, and I'll be randomly choosing a distance of 0.3. So I need a single waypoint is equal to numpy dot uh, random dot choice, and I'm passing the waypoints here and up to 0.3 meters. Although you can change this value as well up to 2. I think you can. Now I need to create another function. This is gonna handle all the stuff and return us the control signal, which is going to be a brake, throttle, and steering. So let's do that. And it is I haven't created the object right so far, so let's just create a control vehicle object for our vehicle PID controller. I'll be passing vehicle here, then I'm passing args lateral. Is that the first one? Yep. And args lateral, and I'll be passing KP set equal to 1. Although I don't need to, because I'm already like defining them as what do you say those things? When you pass arguments, but you already have, so you don't need to pass them sometimes, and functions still run without telling you that you miss the, like, I'm really bad at remembering names. By default you say those things. Okay, so we need an args lateral and an args longitudinal. Okay. Yep. I don't want to make typos right now because this code is really big. Now I need is to create a function, and I'll be naming it steps. So first call the object, no, name the object, then the function name. So let's name it run step, and I'll be passing the target velocity. I haven't still figured out how to get the desired velocity at every point. Like in the Coursera course, it give you the desired velocity you can get from the way that particular text waypoints file. I got a way to get to create a waypoint text file, but it didn't have the desired velocity, right? So I'm just figuring out if anyone of you knows how to, please mention in the comment section. To help speed up the next video. It will help me speed up the process of making the next video. So it will be any help will be appreciated at this point. Vehicle dot apply control, and we pass in the control signal. So this is going to be running a lot of things at this point. So what I can do is go here, def run step, first thing pass self, because so I need to pass target speed here, speed, and that's it. Here wait a minute, I'm passing something else. So waypoints. So waypoint. Yep. And what I can do is self dot first get the acceleration. Acceleration is equal to self dot, they will call in Longitudinal controller, from where we will be getting our acceleration, and there also I have to create a function which is called run step. Okay, and there I have to pass the target speed. Once again, I don't know how to, so I'm just going to pass a really small target speed so that it doesn't like slide into the lamps and buildings. Also, it did get stuck one time when I was running the project, although it did very well considering it's really bad, but still, I mean, it's something to show. That's why I'm making this video. Otherwise, it's gonna take like another week for me to figure out how to get the desired speed and all this stuff. I thought I'll just do it in the part 2 and part 3, and I don't know. It doesn't look like my channel instead. Later controllers. Also for later controller, I will be getting the steering. So another function, and so later control dot run step. And here I'm passing the waypoint. Okay, and what I need now is a control, and I'm gonna get this from Carla dot vehicle control, and also I'm gonna return this control after doing some work. So first let's create the longitudinal run step function. This is a small one, so here I have to pass self as well as target speed. Here, wait a minute, I forgot something there. Mm, no. For first, we need to get a current speed in. Uh, we need to get the current speed right now. So we have to do some work because the speed that we get is not in the right units. So for that, I have to create another function. So what I will do is current speed is equal to get speed. I'm going to create a function get speed, and then I'm passing self dot vehicle. Okay, let's just copy this name again. Since I do a lot of typos, that's why I have to pass vehicle here, and I have to get the velocity. Vehicle dot get velocity, and return 18 by 5. Let's try it to 3.6. 3.6 into. Oh, there's another. You can just use agents dot tools dot miss and import this function from there as well. I'm just writing it because just so that you know what is actually going on. I mean, there's an actual. You don't even have to write the PID controller and everything all. It is. You just have to download the. I think it is in the agents dot navigation, but still I'm doing it right because I want you to understand how it works. I want me to understand how it works. So well.x to well dot y square and plus well dot z. So it is getting the summation of all the particular coordinate velocity and multiplied by 3.6 to it converts into 18 36 10 18 by 5 and 3.6. Yeah, it's right. Now I will get the current velocity, and what I can do now is return. Okay, so I'm going to create another function. Let's name it PID controller, and here I'll be passing target speed and current speed. So let's create this PID controller, pass self, target speed, current speed, and okay. So first of all, I need to calculate the error. Okay. So error is going to be target speed minus what is the issue? So this one error, I'm gonna append it to the error buffer that we created earlier. So append it. And I think in editing I will explain how the PID code actually works. You for the longitudinal you multiply the proportional component with the error, the differentiation component with the difference between the desired and the actual, and differentiate it. Okay, let me show you how it's done. But so for that we have to have at least two values in the error buffer. So I will just do a quick if condition. If self dot error buffer is greater than or equal to 10, so at least there should be 2. Otherwise this won't work. So the differential component is calculated using self dot. Although in my case, I don't need to because KD value is 0. So even if I skip this part, it will work. But if you want, you can change the value of buffer, change the Cybertruck different, change and all stuff, tweak it around. Let me in the comment section what you set the values. So -1 minus self dot error buffer -2 and divided by dd. So the difference between the first two error values. For IE, I will be doing the sum. So just call a function sum and I can just do itself dot error buffer and integrate it, so I have to multiply by dt. If not, I have to as condition d is equal to 0.0, I e is equal to 0.0 and return. So there should be a particular range between what I want. So I'll be using numpy.clip. It will give me the value in between those two and the minimum and maximum range. So I'll be using numpy.clip here. I'll be passing self dot kp into, so the push component just have to multiply by the error plus self dot kd multiplied by de plus self dot ki and multiplied by ie. Now I have to get the value in between -1.0 and 1.0. So this throttle value must be in between these two particular values and nothing else. So this will give me the longitudinal control, right? Now I want the lateral control. This is going to be tough. I mean, it's a bit more difficult, not that much. If you just have to know one thing right now, okay? That's very easy stuff. Have you heard about cos theta is equal to v dot a dot b divided by a modulus b modulus? So theta is equal to cos inverse a dot beta upon a modulus b modulus. If you know that stuff now, it's simple, it's very easy. I mean, you learn that stuff in like your 11th grade. I mean, it's really crazy that stuff that people talk about is never gonna help you. It's helping me right now. So let's create another run step. I'm not getting recommendations anymore. Yep, here it is. So here I have to pass self and waypoint, and I will return. I don't know why I could return function in the first place if I'm just returning it. I mean, it's like lambda function. What do you call that function that returns everything in C++? It was, what is the name? I don't remember. I think I have to revise. No, what I haven't learned so far. So I'm creating a set of PID controller like the last time, passing the waypoints. And the get transform to location and rotation, so I don't have to write get transform again and again. Vehicle dot get transform. Okay, so let's now create a function def PID controller, pass self waypoint and vehicle transform. Okay, and column. So we will have a we begin. So it's gonna be like front rear axle, then the distance between the waypoints. Then we're gonna get a vector. Then we're gonna use like cos theta, get the steering angle that we want. That's what we're gonna use. I think I'll put an image in that editing if I found one. Hmm, I haven't so far, but that's how I visualize it myself. I can be wrong, so I have to find an image. I think vehicle transform dot location v and is equal to. So this one is a bit tricky, but I think you can understand it. We have the begin position. We're gonna add with the x and the y components of the theta. So we're going to use this Carla dot location x is equal to math dot cos component of, first of all, convert that into radians. So I'm not doing any typos. I think so. Vehicle dot transform dot rotation. Something isn't right here. We're definitely have to make a typo here. No, it's fine, it's fine, it's fine. No, it's not. I made a mistake somewhere here. The code. No, I don't mean like in the I'm tapping on the code I'm looking on. No, it's okay. So rotation rotation dot j. So you know how the j angle is the difference between the y component and the direction you're moving in. So you're gonna calculate the x and y direction, and then you get it right. I will put an image. I hope so. If I found one. Similarly, for y is equal to the sine component, and what I want is math dot radians vehicle transform dot rotation dot va. Pretty big line. Okay, so got the front end position. Now I want to get now we're getting a numpy array of the front end position as well as the z. So np dot array vn dot minus v begin dot x v n dot y minus v begin dot y comma 0.0 w vac is going to be the difference between the waypoints that is closest to the road and the beginning position of the car, and using where it is going and where the waypoint, we are going to put the dot product of that particular arrays divided by the modulus, and cos inverse we will get the theta. So numpy dot array. I'm making no sense right now, right? I have to find a way to explain this, but trust me, it works. Transform dot location dot x minus v begin dot x, comma, waypoint dot transform dot location dot y minus v begin dot y, comma 0.0, that is a z. Now let's create a dot, and this is going to be math dot a cost, that is the cost inverse. I told you earlier. We'll be needing lp.clip, so I want a value in a range between -1 to 1. Check with -1 to 1. lp.clip lp.dot this will be dot product between vec and vec. Then I have to divide it by so you know what, like np dot line alg dot term functions to it sort of like a summation of the values square it then underscore then square root, so it's going to be like the modulus. And the np dot line dot norm, and I will be passing vec and the range, which is this 1.0, comma 1.0. Now I will find the cross, and if the cross length is not greater than 0, then I have to inverse it, multiply it by -1, otherwise we'll be so numpy dot cross vec wvec. So if it is equal to 0, that means when is equal to 0, when it is parallel, what is it, when it is, yeah, I think when it's 0 degree, sine 0, same exercise. If it's less than 0, then dot is equal to dot into equal -1. The theta will be reversed, preceding angle, otherwise it's not. Then we will be appending it to our error buffer dot append the dot, and here is the main part, and we are almost done now. If length is self dot error buffer greater than equal to d is equal to self dot error buffer -1 minus self dot error buffer -2. Since it's being the d component, I'll be dividing it by the dt, self dot dt I e is equal to sum of self dot error buffer and multiplied by self dot dt. Okay, and we have read for the else condition. Else de is equal to 0.0, ie is equal to 0.0, and finally return np dot clip self dot kp into dot plus self dot ki into ie plus self dot kd into de comma -1.0 to 1.0. Okay, so almost done here. Just a little bit processing I have to do here now. I have to put some if conditions because I don't want very abrupt changes since it is 0.03. So I have to put some if conditions in here so that I don't have like very big changes. So if acceleration is greater than equal to 0.0, control dot throttle is equal to minimum between first the absolute value of acceleration as well as the self dot max brake and control dot brake is equal to 0.0. Otherwise, else, what is the max throttle anyway? Value was 0.75. Like I said, not too abrupt. Control dot throttle is equal to 0.0 and control dot brake is equal to minimum absolute acceleration. So which one is less? And self dot max brake. Okay, so this is for acceleration. Now I want for steering. So if current steering, have a look at past steering variable so far. No, I haven't. I need a past steering as well for the reference. Self dot pass steering. And I can get this by self dot vehicle self dot vehicle dot get control dot steer. So what I want is if current steering is greater than self dot past steering plus 0.1. So not want a very big change in the steering as well. So I will be using current steering is equal to self dot past steering plus 0.1. Else if LF current steering is less than self dot past steering minus 0.1. Current steering is equal to self dot fast steering minus 0.1. If current steering is greater than equal to 0, then steering equal minimum self dot max steering current steering. Okay, so minimum between the current steering and the max steering. Else, if it's negative, then maximum value between max steering and current steering. Steering is equal to max minus self dot max steering, and I was going to get an error here. Okay, current steering. Okay, and I think okay, now I have to just set the values of the control, and it's done. Control dot steer is equal to steering control dot hand brake is equal to false. Control dot manual gear shift is equal to false. Self dot fast steering is equal to steering. Yep. Since I already have set the control dot throttle here and here, so I don't need to mention control dot throttle. And this will return the value when applied here, and you're done. Just one more thing before this end. I have to do some image processing later. So what I will do is, in the next part that we'll be using a blueprint library dot find sensor dot camera dot semantic segmentation. Okay, camera pp dot set attribute image size x, 800. Just copy this and image size y, and field of view '90. Camera is equal to world dot spawn actor camera vp. I have to first create a camera transform is equal to Carla dot transform Carla dot location, and it's going to be x is equal to 1.5, y equal to 2.4, as well as yeah, that's it. And spawn actor, I will just pass camera transform and camera dot listen equal lambda uh, image uh, image dot save to disk uh, output modulo 0.60 modulo image dot frame. So this will number it what I want, and I want Carla dot color converter dot city scapes PALETT. Okay, this will give me the semantic camera. I also need depth camera, so what I'll do is paste this. You just call it depth. Don't need to set attributes. I'm just going to call it DEPTH depth camera transform. Okay, and color converter log arithmetic DEPTH depth. Okay, we will see this in action in a moment. For now, let's just comment it, save the code. Where is our two PowerShells? Python second.py and need this one, need this. This will take a moment now because it's in hard drive, so it's a bit slow. But I think it is going to work now. I hope so. Okay. I think it's been almost an hour since I recorded this video. Yep, definitely more than an hour. I think I've heard it a lot. Come on. Research is working. And what? 970. Okay. It should be an hour. Give me a moment to think. We have a corner issue here. Okay, we're back. Set location. D city temp. Open the PowerShell. Let's see. I hope it works now. Fish what? Self line. Go to File Explorer. Example. Let's one text. What is the issue? 937. Okay, that's it. Yep. Oh. Hmm. Map has no. Oh, it's actually I know what's this issue. I have got this earlier as well. Like, notice line 163. It's only waypoint. Waypoints. It's dot next. 165 button 5 waypoint control signal left before assignment. I don't know how I'm going to just quit just because of these mistakes. The AD controller is not defined. Where 987. You know what? Not sure it's just because of this thing or not, but mm, oh, PID controller has no object error before line 90. You don't? Oh, it's transform has object location. We begin. Come on. 167. Data is not defined. Line 91. Similarly here as well. Control is not defined. Oh, here it is. You can see the vehicle trying to get to position without hitting the lamp. Okay, let's see. Okay, I think I have made some mistake in the code. Where I think I know. I think I know. Okay, looks like working fine now. Mm, mm, yeah, I think now it works as I wanted it to, and pretty damn good. Looks like it's following the line pretty well. And this was an error that I made earlier. I was just setting the control throttle. The changes were too abrupt. It was set to like 0.75. That's what was a mistake here. And now it works fine. I just put a fast forward image out because if I increase the speed anymore, it's gonna collide. I can handle it. But at this speed, I have actually worked with it and it works pretty fine. But you may be thinking, hey Deepak, what's the point? So, so it's like this. Save it. I just want to make sure that uh, at what do you say, at curves it works fine. Because those are the difficult part. Let's see. Let's see. Please don't do anything silly. But at this point, it isn't getting any waypoints right now because I think it's like junction and yes, like jam. I did it. Although it's not following the traffic signals at this point. As you can see, I can put a code for traffic signals, pause it until it's green, and it will work fine. You know what? I'll show you one more thing here. I'll open another PowerShell, set location d cd tab window python API examples python npc spawn npc.py. I just want to follow rules perfectly. Here now you have the people. We haven't created anything yet, but I think it works fine. Now what we can do is, with it, this is still running. I will do is here and here. What 182 equal. That means there as an error as well. Equal. Save it. So this was okay, and now we will be having this. You can see it's slowed down a lot. I mean, there's obviously a lag here. Yeah. Okay, so here is our car, and it is storing the image of death. And it was go to File Explorer, go to D, sample, depth image, and it is should be creating more now. What not? How come it's not creating more? I don't get this point. Is it the code? Okay, if it's storing it as the output, we have to check the output folder. Yeah, now you can see I think it will be creating more. So yep, right now it created one. So what we can do is like look at this. Now you can see it's really slowed down right now. And unfortunately there is no vehicle. I want you to see a vehicle and how it looks then. But I think we should not push it anymore. There was a pedestrian here, but What I can do is now exit this and exit this. Yeah, I haven't deleted the camera, I forgot to. But yep. What else? Image segmentation you want to see? So comment this. What? Save it. Rerun it. You should be having it now. Unfortunately, it is now getting really hard to use. Okay, so we have a vehicle now that's landed, and if I go here, it should stop having some images here. It is the same folder. Do is Control Alt delete. It is clicking it. So why not? So guys, I think that's it for the video. If you like it, subscribe, and I hope I see you in my next video. Oh, there it is. Yeah, but I think it's pretty slow right now. I don't know why, but the keyboard is burning. So I think I'll really push it this time. So if you like this video, subscribe, press the bell icon, and I hope to see you in my next video. Thanks for watching.